Hi there, Year 8. Welcome to today's maths lesson. I'm going to start off with a quick starter for you. Please pause the video for 5 to 10 minutes and in your light blue books or on a scrap piece of paper or on a mini whiteboard, whatever you have to hand, please have a go at these questions. Can you work out 28 times 9, 7 plus 9 minus 7 cubed? Can you expand this bracket? Work out 0.3 times 0.08, 5/12 plus a third, and then there's an extension question to do on the right hand side. Please pause the video and spend 5 minutes on those questions now, and then I'll go through the answers. Okay, I'm going to go through the answers. The first question, if you'd done a column multiplication or a grid multiplication, you'll have got 252. The second one, you needed to use your bid maths, so 9 minus 7 gives us 2, 2 cubed gives us 8, and 7 plus 8 would give us 15. Expanding this bracket, x times 2x gives us 2x squared, plus 9xy. For the next one, you'd have done 3 times 8 and then divided that by 1,000 to give you 0.024. And if you added together those two fractions, you'll have got 3/4. For my extension question, working out your answer in standard form would give you 2.376 times 10 to the power 4. Well done if you got that right. Okay, we're going to head into today's diagnostic quiz. So A, B, C or D for 5 questions, and I'll go through all the answers at the end. As we go through it, feel free to pause the video if you need an extra minute or two to work out your answer. Question number 1. The highest common factor of two numbers is 6. The lowest common multiple of the same two numbers is 60. What are the two numbers, A, B, C or D? Question number 2. Can you find the highest common factor of 12 and 15 for me? Question number 3. Which of the following is a prime number? Question number 4. Which of the following is not a recurring decimal? Remember, to convert a fraction into a decimal, you need to do a bus stop division. For example, if I was doing a third, I'd do 1 divided by 3. And final question, can you convert 2/5 into a decimal for me? What's 2/5 as a decimal? Okay, I'm going to go through the answers. For question number 1, the highest common factor of two numbers is 6, the lowest common multiple of the same two numbers is 60. Those two numbers are 12 and 30, so the correct answer was B. For question number 2, if you're trying to find the highest common factor of 12 and 15, well, the factors of 12 are 1, 2, 3, 4, 6 and 12. For 15, we've got 1, 3, 5 and 15, so the highest common factor is A3. In terms of prime numbers, the only one that's a prime number, i.e. it only has two factors, 1 in itself, is 2, so the correct answer was A. For the next one, if you've done a bus stop division, you'll have worked out that 1/5 is equal to 0.2, and that's not a recurring decimal. And we can use that for this example. If 1/5 was 0.2, 2/5 is going to be 0.4, so the correct answer was B. We're going to start by recapping how to expand a double bracket. I've got x plus 3 and x plus 1, and I'm going to expand it. On your mini whiteboards, can you pause the video for 30 seconds and expand that bracket now, please? Okay, hopefully you'll have got x squared plus 4x plus 3. So you've done x times x gives you x squared. 3 times x gives you 3x, 1 times x gives us another x, so I've got 4 x's altogether, and then 3 times 1 gives me positive 3. Now I want us to model a new mathematical way of thinking, okay? And I'm going to show you how to do this first, and then I'm going to give you some to do. I've been given x plus 3 and x plus 2, and I've been asked to expand this bracket. Now I'm not going to work it out. Instead, I'm going to try and predict what that expansion might look like. Without working it out, I'm going to try and predict it. Now what we might predict is that, well, the x plus 3 has stayed the same, but the 1 in the second bracket has become a 2. That's what's changed compared to our previous answer. So I might predict that in some way it's going to change this 4 and it's going to change this 3. A good prediction might be to say, well, the 1 has gone up by 1 and has become 2. Therefore, I think my coefficient of x is also going to go up by 1. And my number on the end is also going to go up by 1. That would be a good prediction to come out with. However, when I expand it, I find that I get x squared plus 5x plus 6. So the coefficient of x, I was right, it has gone up by 1. But the 3 hasn't become a 4, it's become a 6. But why? We need to look at how we found the coefficient of x4 and how we found the 3. Now the 4 came from the addition of the 3x and the 1x. So I've added together the 3 and the 1 to give me 4. To get the 3, I've multiplied the 3 and the 1, and that's given me the 3. So now, if I were to predict this one, I would say, well, I now need to add together the 3 and the 2, which will give me 5x, and multiply the 3 and the 2 to give me 6 on the end. If I do that, and I predict that, I would get the correct answer, x squared plus 5x plus 6. Here's one for you to do. Can you predict what you think this expansion is going to be? Pause the video for a minute and have a go. Okay, so hopefully you might have predicted this. You might have predicted something else, and that's fine. But I've worked out that, well, I've got to add together 3x and 3x to get my coefficient of x, which is 6x. And to work out the number on the end, I've multiplied together the 3 and the 3 to give me 9. And explaining that, 3 plus 3 gives me 6, and 3 times 3 gives me 9. And that's how I might explain it. I would then check it, doing a grid expansion. I've got x here, I've got x plus 3 along the top. Down the side, I'm multiplying x plus 3. Filling in the grid, x times x gives me x squared. 3 times x gives me 3x. 3 times x gives me another 3x. And 3 times 3 gives me 9. Adding together my grid, that gives me x squared plus 6x plus 9. I've checked my answer and it's correct. So using that behaviour, can you please predict what you think the answers to each of these is going to be? So calculate the first one and then use that to predict what you think the next one's going to be, and then work it out to check it. Please spend about 5–10 minutes on this, and if you finish, have a go at writing your own sequence of intelligent practice questions in the same way, where you can use the previous answer to help you predict the next one. Okay, here are the answers. Please check your work and see how you did. If you did write your own sequence of intelligent practice questions, please can you post me a photo of it or a document of it on Google Classroom, because I want to see how you're thinking, how you might design a series of questions in the same way, where you can use the previous answer to help you predict what you think the answer to the next one's going to be. So why are we doing this? So far we've been looking at expanding brackets. We're now going to look at factorising them, so putting the brackets back in. And to start off with, what does the word sum mean? Well, the word sum means the result of adding together numbers. The word product is the result of multiplying numbers together, and we're going to use these now. In your dark blue books, can you write me the title Sums and Products? You can write the date as well. The date today is the 11th of January. I'm going to start by modelling 2 examples, and then there's 2 for you to do. So here's my examples. Find the sum of 9 and 3. The sum means I'm adding them together. 9 plus 3 is going to give me 12. If I've got 9 plus negative 3, that's going to give me 6. If I've got negative 9 and I add on 3, that's going to give me negative 6. And if I add together negative 9 and negative 3, that's going to give me negative 12. If I'm finding the product of these numbers, that means multiplying them together. So for the first one, 9 times 3 will give me 27. For the second one, I've got positive 9 multiplied by negative 3. So that's going to give me negative 27. For the next one, I've got negative 9 times positive 3. That's going to give me negative 27. And for the last one, I've got a negative times a negative. That's going to give me a positive, so positive 27. Over to you guys in your dark blue books. Please find me the sum of these and the product of these. Pause the video for a minute and work those out now, please. Okay, I'm going to go through the answers. The sum of 10 and 3 is 13. The sum of 10 and negative 3 is 7. The sum of negative 10 and 3 is negative 7. And the sum of negative 10 and negative 3 is negative 13. You might have noticed a pattern going through these. For the product, 10 and 3 gives me positive 30. Negative 3 and 10 gives me negative 30. Negative 10 and 3 gives me negative 30. And negative 10 and negative 3 gives me 30. Now we're going to look at working the other way. I'm going to try and find two numbers where the sum is 5 and the product is 6. So the sum when I add these two numbers together is going to give me 5, and the product when I multiply them together is going to give me 6. Now two numbers that would give a product of 6 could be 1 and 6. Could also be 2 and 3. Those are my two options. I need them to sum, add up to 5. So the option that I'm going to choose is 2 and 3, because 2 plus 3 gives me 5, and those are my numbers. For my second example, I want the sum of two numbers to be negative 1 and the product to be negative 30. Now pairs of numbers that would give me a product of negative 30 could be 1 and negative 30. They could be negative 1 and positive 30. It could also be 10 and negative 3, negative 10 and positive 3. I could have positive 5 and negative 6, and I could have negative 5 and positive 6. All of those pairs would give me a product of negative 30. However, I need a sum when I add them together of negative 1. Well, 1 and negative 30, when I add those together, that's not negative 1. Neither is negative 1 and positive 30. Neither is 10 and negative 3. Neither is negative 10 and 3. 5 and negative 6. If I add together positive 5 and negative 6, that will give me a sum of negative 1. So this is my correct set of numbers, 5 and negative 6. We'll just check the other one doesn't work. If I add together positive 6 and negative 5, that gives me positive 1, so that one's not going to work. So the pair of numbers I would choose is negative 6 and positive 5. Over to you guys. In your dark blue books, can you find me two numbers where the sum is 10 and the product is 16? And can you find me two numbers where the sum is negative 5 and the product is negative 66? Pause the video and work those out now, please. Okay, I'm going to go through the answers. The first one, the two numbers have got to be 8 and 2. If I multiply together 8 and 2, I get 16. When I add them together, I get 10. For the second one, the answers are negative 11 and 6. When I add together negative 11 and 6, I get negative 5. The product of those two numbers, when I multiply them together, is also negative 66. So those are the correct answers. Please switch to your light blue books now, and can you pause the video and spend 5-10 minutes finding two numbers that will add together to give the numbers in this column, but multiply together to give you the numbers in the other column. Pause the video and work those out now, please. And these are the answers. Please check your work and see how you did. Okay, but why are we doing this? Let's put everything we've learnt so far all together. If I've got x squared plus 7x plus 12 and I'm asked to factorise it, that means putting the brackets back in. I know that I make the coefficient of x, this number in front of x, by adding together the two numbers in the brackets, these two. I also know that I make the number on the end by multiplying together the two numbers in the brackets, or finding the product. So I'm going to use this to factorize a quadratic. So I'll go through one example, and then there'll be one for you to do in your dark blue books. Can you write me the title, Factorizing double brackets, please, and then pens down, eyes on me, while I go through this example, and then there's one for you to do. So I've got x squared plus 9x plus 20. And I know that in my bracket I need two numbers that are going to add together, sum to give me 9, and multiply together, product to give me 20. Pairs of numbers that would give me a product of 20. Well, I could choose 1 and 20, but that wouldn't sum to give me 9, so it's not those. I could choose 2 and 10. That also wouldn't add together to give me 9, so I can't choose those. I could choose 4 and 5. That would add together to give me 9, so those are the numbers I'm going to choose. So if I factorise this expression, the numbers in the brackets are going to be x plus 4 and x plus 5. To be doubly sure, I could then expand this double bracket and check that it gave me x squared plus 9x plus 20. Over to you guys. In your dark blue books, please pause the video for 2 minutes and factorise this one for me. Put the brackets back in. Okay, I'm going to go through it. This time I need the sum to be 12 and the product of the two numbers to be 20. Now, two numbers that could give me a product of 20 we've already been through. We could have 1 and 20. That wouldn't give me a sum of 12. We could have 2 and 10. That would give me a sum of 12. So those are the ones I'm going to choose. Putting the brackets back in, that's going to give me x plus, there's my 2. And in the other bracket, I've got x plus 10. And I've factorised it. I've put the brackets back in. Please make sure you've got this correct in your dark blue books. On your mini whiteboards or in your rough books, please factorise this one for me. Remember, you need the sum to be the coefficient of x and the product to be the number on the end. Pause the video if you need, otherwise I'm going to go through the answer. This time, I'm going to get x plus 4 and x plus 2. Because 2 plus 4 gives me 6, and 2 times 4 gives me 8. Here's another one. Can you find two numbers that sum to give me 10, multiply to give me 21, and factorise this expression for me? Okay, this time the two numbers I need to choose are 7 and 3. So I'm going to factorise it as x plus 7 and x plus 3. Over to you guys. In your light blue books, please pause the video for 10 to 15 minutes and have a go at factorising each of these expressions for me in the same way. If you finish, have a go at my extension question on the right hand side. Pause the video and spend 10 to 15 minutes on these questions now, please. And these are the answers I was looking for. Please check your work and see how you did. And that's the end of today's lesson. Please head on over to Google Classroom and submit today's exit ticket for me so I can review your learning and see if you've got any misconceptions that I need to clear up next lesson. Thanks very much for listening, Year 8, and have a great day. Bye-bye.